Hello viewers, welcome to the second live session of this NPTEL MOOC course on mathematical portfolio theory. So I'll first let me have a look at the response sheet that was provided to the learners. And as I can see here, so far I'm still awaiting any queries that people might have. Uh, and For the time being, now that we have started the live session, I request learners to post their questions in the chat box so that it's easier for us to address the questions. So since there are no questions on the spreadsheet that was circulated, so now the chat box is now open to any questions that you might have. So please start posting your questions on the chat box. Okay, while we wait for some questions that might come in the chat box, let me just do a brief summary. What we have done so far is we have uh, released up to week 9, that is, we are done about 75% of the course, and we have covered primarily probability theory, and we talked about mean variance framework and non-mean variance framework. And Subsequently we started looking at optimal portfolio and consumption, first in the discrete time setup using the dynamic programming principle, and then in the continuous time setup making use of the Hamilton-Jacobi-Bellman equation. And So the topic that is essentially left is we have three main topics that are left for the last 3 weeks, namely the bond portfolio optimization, risk management using value at risk, and finally in the last week we'll talk about the topic of using MATLAB in order to using some inbuilt data sets that are available with MATLAB and how they are amenable to be used in case of actual portfolio construction. And while we will do that, the last week of sessions will also include things that are available in the MATLAB toolbox just beyond what we did in the class, and will give you a much more realistic perspective on the practical application in designing of optimal portfolios as well as risk management. And from the mathematical point of view, those concepts are fairly challenging. But once you look at the MATLAB setup, at least it will give you an intuitive idea as well as a way of implementing uh, a practical scenario where you can actually download your data set. Essentially, you just look at what the historical data set for various assets are, and then you can make use of that to determine your own optimized portfolio subject to various constraints, such as the number of assets that you can purchase, or the turnover or the transaction costs and so on, and what is going to be the associated and the corresponding risk that is associated with those portfolios by making use of the concept of value at risk. So this was just a brief summary of what we have done so far and what you can look forward to. And as I've said that now we are open to for questions. So so please post your question on the chat box. So looking forward to your questions to be addressed. And just a reminder again that in addition to these live sessions that we are having, you of course have the forum, the discussion forum, where you can post your questions on a regular basis to be addressed by the course team. So you have a small audience that is watching, now. So I'd like to invite questions from them on the chat box. So far we have completed the submission deadline for the first 7 assignments, and the solutions for those 7 assignments have already been posted on the course webpage. So, so kindly post your queries. So we'll wait for some more time. Uh, Again, inviting. So we have questions from our learners. So as already noted in the chat box, our session is limited to 1 hour. So please post your questions during this time window. So while we are waiting for some questions to be posted by our learners, let me just talk a little more about some of the other topics that were done subsequent to our last live session. So in the last live session, our focus primarily was on the mean variance framework and the portfolio theory, the optimization, and the probability theory. And in the subsequent to the last session, we have talked about more about the non-mean variance framework and the optimization. Okay, Siddiqui 49 has talked about elaborating on Black's CAPM. So Siddiqui, can you just provide me with the lecture number where we had this topic elaborated? Can you just quickly provide me the lecture number? That would be very helpful, so that I can go over the topic again. Siddiqui 49, can you please point me towards the lecture number where we had discussed this topic so that accordingly I can retrieve that and talk in the context of that lecture. Siddiqui 49, I am still waiting to hear back from you. Okay, fine. So you talked about this. Uh, it was not discussed that as a part of the syllabus, so you kind of you can elaborate. Okay. So let me just quickly talk about this. So as you recall, the CAPM was essentially it gave you the formulation for the risk, the return of a particular asset in terms of the beta of that asset, which was an indication of the sensitivity of the particular asset from the perspective of risk vis-a-vis the market return. And so this the black model essentially is something which is known as the zero beta CAPM, and the zero beta CAPM, as the name suggests. So at the end of the day, zero beta CAPM, as the name suggests, is essentially will involve an asset that essentially has a zero beta. That means it is insensitive to the overall risk of the market. Uh, so in this particular case, what happens is that the, the zero beta portfolio uh, was essentially designed so as to provide an alternative to the CAPM framework, where instead of having a risk-free asset based on the assumption of the CAPM that you have the existence of a risk-free asset, you to talk about the replacement of that asset in terms of by replacing the risk-free asset with some asset which is a zero beta vis-a-vis the individual asset. Now, the purpose of the black CAPM or the zero beta the zero beta CAPM is just to was an extension of the basic CAPM in order to relax the condition that was there in the CAPM, which assumed the existence of a risk-free asset. So the zero beta CAPM essentially, it does not assume that the existence of a risk-free asset is there, and accordingly it modified the the CAPM framework or the CAPM formulation by getting rid of the zero beta portfolio, and instead replacing that with the return of the risk-free asset. So that is essentially the summary of what I mean by as a zero beta model. So in this case exactly, so more specifically in mathematical terms, the zero beta CAPM will be given by the exact similar formulation to the usual CAPM, except that instead of the risk-free rate appearing in two places in the formulation, we replace the risk-free rate by the expected return of a particular portfolio or an asset which you will define as Z to indicate that this is for the zero beta. And so according to the formula is going to give you is be given by expected return of the ith asset is going to be equal to the expected return of the zero beta portfolio plus the excess return of the market over the expected return of the zero beta portfolio multiplied by the beta of I. So it is just, it is the same, in spirit it's the same thing as the usual CAPM, except that you change the risk-free rate in two places with the expected return of the zero beta portfolio as an alternative to the original CAPM by relaxing the condition of the existence of a risk-free asset. So that is the summary of what we mean by the black CAPM or the zero beta CAPM. So I hope, Siddiqui, I have 49, I have answered your question. Okay, so thank you, Siddiqui, for commencing our session for today with your interesting question, and which of course provided some input on this topic to other learners. So I now invite others to pose their questions. So for those of you who are interested, there are lots of different extensions of CAPM. So for example, there is an extension where you could relax your condition on the assumption of the basic CAPM that there are no taxation on your capital gains and that there are no taxations on your dividends. You could relax other conditions, like for example, assuming that you cannot liquidate certain kind of assets. So that is one thing you can take care of. So one of those, and this Black's CAPM is one of those CAPMs that are extension of the regular CAPM. And also when we were looking at our discussion on the non-mean variance framework. So in the non-mean variance framework, we have equivalent of CAPM where we, as well as the CML and SML. So both of this. So in case of CML and CAPM, we had equivalent versions in the non-mean variance framework where we replaced the standard deviation that appears in the CML by the semi-deviation that appeared in our discussion on non-mean variance framework, as well as we had some sort of a semi-deviation beta, which was the analog of the regular beta, but it was applicable in case of the non-mean variance framework. So there are many such alternatives to CAPM. With a lot of emphasis on looking at, so these extensions are essentially, you can view this being driven by providing alternatives from two perspectives. The first perspective is that you take it as an alternative by relaxing the condition of the original CAPM, and the second approach that you have is so the first is just relaxing the condition, and the second is essentially driven by downside risk. So that means the non-mean variance framework. So you can look at the extension of CAPM both in the mean variance framework as well as the non-mean variance framework. But intuitively you can see that there are the extensions that you get from the basic CAPM. They are very very intuitively consistent, and a lot of the times they if you again impose those conditions in those setup, then you will again recover back your original CAPM. So for example, if you look at the formulation in case of the capital gains tax, if you take the rate of taxation to be equal to 0, and you apply that to the formula of CAPM for the taxation framework, then it immediately reduces to the scenario when there is no taxation. So you are able to actually recover back your original the CAPM formulation. So depending on the requirements, you can actually look at a lot of variations of CAPM. But from the applicability point of view, of course, the basic CAPM is very appealing and easier to understand intuitively, as well as the mathematical derivation is straightforward, and the intuitive understanding, of course, is much simpler as compared to the extensions where the algebraic computations that are required in order to arrive at the final form of the equivalent CAPM can sometimes be actually quite involved. So again, can we have some more questions from our audience? So again, from the mathematical point of view, the other topic that we did one optimal portfolio and consumption. That was sort of that's a very interesting topic, and it's also a very useful topic in the sense that its application is not just restricted to portfolio optimization, but can be extended to other engineering problems. In fact, the dynamic programming principle is a very very important tool in case of engineering optimization problem. So again, I request our learners to please pose their questions. Oh, how are APT factors chosen in practice? Okay, so the APT, the concept of APT factors is mostly driven by empirical data analysis. So there is no hard and fast rule as far as the APT factors are concerned. You will have to identify in a sort of qualitative manner as to how are your returns getting affected by several factors. So for example, a simple case of the APT would be the reduction to the CAPM framework. So in the CAPM framework, you know that it's a special case of APT, and you know that you have one factor, namely the market. So on top of it, if you have a multi-factor APT setup, then you have to make a decision as to what are the factors that you believe, and this is a qualitative assessment that you believe that are affecting your returns of the particular asset. So, for example, just beyond the market portfolio, the other factors could be GDP, it could be the exchange rate, it could be the interest rate that is prevailing in the particular market where you are looking to model your return. So, accordingly, you can keep adding those factors, and the APT factors, once they are chosen, then you have to do some sort of a fitting to the empirical data in order to obtain your corresponding any parametric values by using some sort of a curve fitting technique. But in summary, the APT factors have to be chosen in a qualitative manner, as I said, depending on your understanding by direct observance, your understanding of the uh, market events or market variables that are actually affecting the return of any asset that you are modeling through the APT. So it's a more of a uh, non precise or rather I would say it is not really exact science as to how you can actually choose the APT factors. It will require you, of course, to have an intuitive understanding and clarity of the behavior of the global behavior of the market as a whole, and identifying the ones that you think are applicable. And this is consistent with your general principle of modeling at large, where you have to make a judgment call as to how you are going to model it and what are the things that you are going to include in the model, which obviously you cannot include a large number of things in the model. So as I said, it's your call, and the simplest case is the single factor model where the market, and by market I would typically mean some sort of market index, maybe exchange traded fund or some market index such as Sensex and Nifty, and then on top of it you can take other factors also that would come into the picture. So I hope your question has been answered to your satisfaction, Siddiqui 49. So I was hoping our other audiences would post some questions. Well, Siddiqui, I mean, that is not necessarily the case. The attempt is, of course, always to beat the market. Uh, there are lots of factors like, for example, if you uh, some of the potential factors are the inflation, gross national product, changes in yield prices, and so on. So theoretically speaking, if one can find an accurate set of factors, he or she can beat the market. See, beating the market, this is a very open-ended question. But in principle, you should be able to. In principle, you should be able to set something up where you can beat the market. But please remember the fundamental assumption of arbitrage pricing theory that you are assuming that there is no arbitrage. So the way it is set up, you really don't expect that you will be able to find something that beat the market. but you can actually set up certain factors that you are able to beat the market. But at the end of the day, please understand that the arbitrage pricing theory is a model to estimate the returns. And that in order to estimate the returns, what you have done is that you have made use of a model in terms of certain factors. Now the question here is that you are that is your identification of the factors that are affecting the return, and then you are making a projection of future returns made on that model. Now the difficulty with this is that you are using that return model to make future projections, and that future projections does not necessarily need to be realized. So at the end of the day, you have to make use, just because you have chosen a factor model, and a factor model chosen reasonably well by doing the curve fitting to the empirical past data, it does not necessarily mean that you will actually be able to beat the market, just because you see at the end of the day it's a model to do the return, but it does not necessarily mean that eventually the returns, that your choices of factors may not necessarily lead to obtaining a better return. So it is not really, at the face of it, it is not a portfolio optimization problem, that you are doing a portfolio optimization, you are choosing a certain amount of weight, and because of a very efficient way that you supposedly have figured out in order to make an optimal choice of your portfolio, that might lead you to try to achieve a scenario where you are able to build the market portfolio. But arbitrage pricing theory at the end of the day is essentially, it is looking at the return variables. So perhaps you can make use of an optimization technique applied on the arbitrage pricing theory model, and then you can find out the necessary weights. So yes, if you look at it from the perspective of figuring out in the paradigm of an optimization problem, you might be able to actually achieve a return that actually beats the market. Or if you look at the arbitrage pricing theory, you might end up getting something that is actually able to beat the risk-free rate. So yes, in principle, you should be able to use the arbitrage pricing theory in conjunction with some sort of optimization to be able to figure out. But just looking at but coming to your question specifically, just looking at the factors and identifying the factors to get a return model, I cannot see how that particular consideration in isolation can actually lead you to be able to figure out a strategy to beat the market. See, any strategy to beat the market, at the end of the day, any strategy or even a basic design of a portfolio will require you to actually implement some sort of an optimization, because that ability to beat the market cannot be just only done on the basis of what model you have for the return. You have to have some additional inputs in terms of cleverly doing the, especially in terms of figuring out which asset to allocate and which optimization has to be done. So somewhere the allocation of the optimization has to play a role in jointly, a supplementary role jointly with the arbitrage pricing theory. And this is a statement that you can apply to any sort of any sort of model that you are using for prediction of the returns of assets, and consequently that of a portfolio. Okay, Siddiqui, thank you for asking a question. And I was hoping, more people would join this conversation. So now that we have had a few questions, and our conversation is started. So again, I request people, our learners, to please do come forward to put forth whatever questions they might have. So again, we are more than halfway through our session, so please post any other questions that you might have so that we have time to address those questions. So we'll wait for a few minutes, uh, looking forward to your questions. And if there are no other questions, then we can consider closing the session. Right? So please post your questions in the next couple of minutes so that we can continue our discussion. And if if our learners feel the questions have been addressed, then we can slowly look to closing our session. So that's why I'm requesting people to post their questions. So we'll see for a couple of minutes to address any reminder questions. Okay, so it seems that there are no further queries either in the Okay, so Siddiqui has the question. Sir, how do you choose a risk-free rate in the international CAPM practice in during data analysis? So I do. Did I do an international CAPM? I think this is something that was not done in the course. But so I, at this point, I don't recollect what was the exact model for the international CAPM in practice, and I don't think that this was done in the course. So I just have to look it up. So can you please post your question in the course discussion page so that I can actually follow this question up with you. I hope that's okay. So it's very nice that Siddiqui actually is bringing forth various alternatives to CAPM for the benefit of our audience. But in this case, this was not a part of the course as far as I can recollect. So, but I'd of course certainly like to address the question posed by Siddiqui. So, well, I understand that you are referring to a global market portfolio, but I will need to look at the specific equations. And as far as I can remember, this was not done as a part of the of our syllabus or course. So that is why I'm requesting you for some time. So that is why I requested you to please post this on the discussion forum, and I'll follow up with a detailed answer to your question. See, in practice, I mean, there are differences. If you're just looking locally for CAPM in the same market, of course, you can choose your risk-free rate to be the interbank lending rate or the prevailing rate in the market or some sort of an average of this. So there are different ways. So, for example, you can take the rates at which, in the context of a domestic market, you can take the risk-free rate to be the rate that you at which the Reserve Bank lends to the banks or the banks lend or borrow amongst themselves, such as the MIBOR, which is the Mumbai Interbank Offered Rates. But in case of a global market, I mean, from the top of my head, a global in case of a global market, a risk-free rate. One thing that comes to my mind, but of course I'll have to follow this up with a more detailed question, response to your question regarding the risk-free rate in case of a global market. One common interest rate market that is widely used market rate is the London Interbank Offered Rate or the LIBOR rate. So that gives you some sort of a benchmark or rate of interest because that is the rates at which the large banks in London they borrow or lend among themselves, and it is a very large collection of interest rate that is uh, published, and the LIBOR rates are rates that are offered for multiple currencies as well as for multiple maturities. So that means it is the rate at which the London banks can actually do a borrowing and lending in different prominent currencies for different lengths of time. So that is something that I can immediately think of as a possible candidate for the risk-free rate that is applicable when you are looking at a global market. So, for example, if you are looking at, say, the return of a particular asset, you can actually view that return in the context of a certain currency, and you can actually pick up the interest rate of the currency of that particular duration. So, for example, if you have, you can pick up that particular interest rate either from the country, the prevailing domestic rate of the country where on the base where that asset is actually being traded or where the company is based. So, for example, if you are looking at some sort of a international the global market portfolio for a company that is based in India, you can perhaps make use of the MIBOR rate. Or if you are looking at more economies or countries from where the asset comes and which at the same time is one of the currencies in which the London interbank rates are actually offered, So you can consider making use of that particular rate to be one of the possible rates that you can use for the point of view of modeling your CAPM in an international setup. Okay, Siddiqui. So I've just conveyed whatever I could sort of uh, think of based on your question. But of course, I promise to follow this up with you later on. Just please post your question once again in the discussion group, and I'll just follow this up with you. Okay. So yes, Siddiqui, thank you. And also, I suggest, since you have expressed a lot of enthusiasm and interest in this case, so you please, I suggest that you please look up a little more detail about, so please refer to what are known as LIBOR rates. So please refer to the LIBOR rates. It's a very interesting read talking about, how actually borrowing and lending takes place in a single setup in so many different currencies for so many different maturities. And of course, LIBOR rates are some sort of a benchmark as far as the international exchange rate goes. So it's a very useful and important concept to uh, actually go through and study in detail. And I recommend that you please, whenever you find some time, you can go through this and learn more about the LIBOR rates. In fact, a lot of transactions are quoted in terms of the prevailing LIBOR rate. So, for example, there could be a floating rate as far as bank loans are concerned, where you could talk about that the floating rate is LIBOR plus 10 basis points. So, it means the LIBOR plus 0.1%. So, LIBOR actually acts as a yardstick for in a lot of financial engineering setup. Okay, so So as we are coming closer towards the end of our session, so I request you again to please post your questions so that I can address them before the conclusion of the session. Okay, so we'll wait for a little bit in case any remaining questions need to be addressed. So I don't see any more questions either in the doc that was circulated or in the chat box. So, since there are no other questions as it appears, so I wanted to thank people who have joined us today, and also the questions that have been posted, both from the topics that have been covered as well as beyond that. And it is really appreciable that people are looking at topics beyond what is done in the class, be in the lectures, and this enthusiasm is very much appreciated. So as I can see, as I said, that I at this point there doesn't seem to be any more queries that are left to be addressed. So again, reminding you all that please, any questions that you would like to be, any other questions that you would like to be addressed uh, on a regular basis, please post them on the link Ask a Question that is available in the course dashboard, and we'll try to address it as soon as possible. And with this, I think we can conclude this session for today. And I want to finish up by thanking you all for those who have joined us and have particularly people who have contributed to this discussion in a very interesting way and very enthusiastic way. And I look forward to more interaction uh, on the discussion forum. And thank you again for joining for today. So with this, we conclude our session for today.